So welcome everybody to the 6th Sasensei SID event. We're lucky to have Gerhard with us, who's going to be talking to us about structural changes in longitudinal data using SAS procedures and the SAS Datastep. Over to you.
Hello and welcome, and thanks to Ellen for having me. This is Gerhard. I'm based in Austria, in Vienna, and I'm a SAS consultant and SAS data scientist, mostly related to analytical topics. So I'm involved with client sites for demand forecasting, for predictive modeling, for fraud detection, and for a couple of other analytic related things. I'm also a book author for SAS because out of all these projects, I gained a lot of experience when discussing analytical topics and SAS questions with our SAS users. So I thought it's a good idea to write this down and to share it with the community. And I also love to teach analytics and to teach SAS, and I'm a part-time lecturer at the Medical University of Vienna and 2 business schools here in Austria. Today, I'm going to speak about the combination of an analytical topic and a SAS programming topic. So I would like to show you how you can use SAS analytics to automatically detect structural changes in the data and how you can also go and display them automatically in your graphs. So this is what my presentation is all about. And what you see here on the next slide, I like to speak on data science applications and on case studies. And I also started to create a webinar series on that, where I took case studies out of my book. What you're going to see today is very strongly related here to case study number 2, where I have a case study on detecting structural changes. And we will take a look at this, but more take a look at this from the coding perspective, because this is an Sasensei session. So in a nutshell, what I would like to show you here is I would like to show you how you can analyze your longitudinal data as you see them here. And what you see here is the number of airline passengers over the years. And of course, we all know in September 2001, there was this 9/11 event. And this, of course, had also had an effect on the number of airline passengers. You see that there's a drop, and then it slowly came back, and it retained some seasonal pattern. What I would like to show you is how you go and automatically detect the structural changes. So they say, okay, something happened here and something came back here, and maybe this also shows here a little bit of a different way, how you can automatically detect the outliers and the structural changes, and more important, how you can automatically label them on the time axis and say, here something happened and I would like to get this automatically. So what we are going to do is we are going to use analytical procedures. So for example, from SAS Stat, the ADAPTIVEREG procedure, or from ETS, the X13 procedure. This is the analytical part that we are going to use. And we are then going to use a data step and SAS functions to automatically create the REFLINE statements for the SGPLOT procedure. This is what my presentation is all about, and I would like to show you how you can use this. So in a nutshell, what we're going to do here is, in order to have this automatically labeled, you have to walk 3 steps. The first one is that you output the points on the x-axis calculated by the SAS analytic procedures. In most cases, you use the ODS output statement to do so. After you have done so, you use a SAS Datastep to convert this output and these time points into a file creating the REFLINE statements. And finally, you just use the SGPLOT procedure and include this file which contains the REFLINE statements. This is what we're going to do here. Let's first start with an example how you can detect breakpoints. Breakpoints means we would like to see over time, when you have your data, for example, from a clinical trial, so you see the recruitment numbers. So you see there was a phase where it went something like flat, then it went down, then it went up again, and then it went flat. We know when we as humans watch this, this chart that most likely something happened here and something happened here when it came back. But how can we detect this automatically? And there is a very nice method in statistics, and which is also available in SAS Stat, which is called, which has a very complicated name, multivariate adaptive regression splines. So don't be scared out of the name. We won't get into too much details, but this method is very frequently used for non-parametric regression techniques because it fits regression splines into data, and it does a backward model selection to end up with a quite parsimonious model. We are going to use this method not in order to fit an excellent model, but we would like to use this in order to get the points where the regression splines start and end, and derive there our breakpoints in the data. This is the way how we use these regression splines. So this means we have the benefit here. We get a suggestion for breakpoints, and we do not need to specify them in advance. And we can learn from the data. So the data is talking to us, and we see when something happens. So as I already said, this is the data as I presented here. We see something most likely happened here and something happened here. And if we now feed this data into the procedure, we get automatically breakpoints. We get one breakpoint suggested here, one here, and one here. I'll show you in a second how you can do this with SAS code. And I have worked in this clinical trial, and I know that at this time, one of the patients died, and there was quite a discussion whether this is related to the study medication or not. And the medical doctors got a little bit scared whether they should continue to treat patients with this therapy. So the recruitment numbers went down, and only after a study meeting was there to announce this was a very unpleasant event, but it is not related to the treatment. Only then slowly the recruitment recovered and the study took on again. So it's a very nice example how analytics could detect these time points, and we can then relate them to the business context. So let's now take a look how you can do this with SAS. What I'm using here is the flight data, so the airline passengers, as I showed you in the beginning already. If I plot them here in SAS Studio, you see, for example, this is a typical time series. We have a seasonal pattern, and then we see here that somewhere here in September 2001, we see the drop after the 9/11 event, and then it moves further. I also provide here with a second line a smooth series, so it's maybe a little bit easier to see how the average pattern over time moves here in that way. So you can watch that. We would now like to use the ADAPTIVEREG procedure, as I'm showing it here, to say, okay, we would like to model the number of passengers over time. So we build a quite simple model, just saying, explain me the number of passengers over time, and do this using the ADAPTIVEREG procedure. If you do so, we see that the analysis analyzes the data over time and automatically detects breakpoints where something happened according to the change in the pattern. So it automatically adds here lines, and you see it here a little bit better and more clearly. It says, if I would have to interpolate this by linear splines, I see a breakpoint here going up, going down. I see here one close to the 9/11 event, and then a recovery right here. What we now would like to get is, we would like to get the predicted values for these straight lines in order to show them in the data, and we would like to get the time points on the time axis to automatically display it in our charts. How can we achieve this? One simple way is to get the predicted values is if you use the output statement. The output statement just outputs the data that you have plus the predicted value. So you just say, I would like to get the predictions into a variable predicted adaptive, where I now also have the output values. And I also use ODS output to output this table that you have seen here, which contains the list of where did, according to the procedure, a change happen over time. So here we have the SAS date value on the time axis where such a change took place. This means we just need to output this table into a new table which I named not points. If you want to find out how is this magic name for all the output objects, you might be aware that you can just use the ODS trace statement. So if you turn ODS trace on and you run the procedure again, you see that you get here in the log window all the names of the output objects. So everything that is added to the output has a name which you then can recall. And you have here parameter estimates by the backward selection. This is this object, so I just copy and pasted this here into my code to have the output name. So after I've done this now, you see that I get a new data set. And I now have to remove this here, so that you can see easily. I get a data set where I have the time points in, which is already a very good start. So I see the time points, and I now have to convert these time points into REFLINE statements for our plot. And in order to do this, I'm using the file name statement. I'm saying I will go and create a file on a certain library with a certain name on my size, on my local server here. So you see this is empty at the moment. And I will then do the following. I say I create a data null statement, data step. I use these not points that I created in the ADAPTIVEREG procedure. And you see that the first two lines, this is the intercept, and this is just the start of the line. So I can omit the first two lines. I only start with the third line. And here I just have to output the points that I have here. This means in the code I'm saying I'm exporting all where the name is not in basis 0 and basis 1, because these are just the first two lines with the intercept. Then I say everything I have here, I go and pipe it out to the file that I mentioned here. And what I put there is a statement, SAS code, where I'm saying text refline, the value of variable not, text / axis is the x-axis. And if I run this now, you see that my directory gets populated, and I receive a file where I have the REFLINE statements automatically with the date labels in. So I say, at this date label, I would like to have a reference line, at this one, at this one, at this one. I can now use this file automatically to create reference lines in an SGPLOT procedure. So I'm just doing SGPLOT procedure. I create time series plots with the predicted values that I added earlier, and I include this reference file. And by running this, you see that I automatically get my original data that I had, my forecast data, but I also get the reference lines automatically added here to my chart. So this is a very convenient way if you want to run this over and over again on fresh data, or for other regions, for other analysis subjects. And it would be very hard always to code this manually. I look at the output of the ADAPTIVEREG procedure, and I have to write down the date values. This is a very easy automatic way. Just take the data set, create the value of the date value, add it to a REFLINE statement, reuse it here. So this is very easy to achieve. I would quickly like to show you one more example how you can do this with outliers. So at the moment we looked at structural change. So we were checking whether the slope or the decline of the curve changed. What we are going to do now is we would like to find other outliers in the data. And outliers can be different things in data. So for example, it could just be a pulse, a single event, something happened. It could be a level shift. At a certain point, the time series changed and ran for a certain time, maybe came back later on. It could be a ramp, it could be a temporary change. There are procedures in SAS ETS, for example, the UCM procedure, the X13 procedure that automatically analyze your time series and identify those points that deviate from the average pattern quite a lot. So these procedures can do this automatically for you. However, be aware you need to have a SAS ETS license or via a SAS econometrics license. Or if you want to use the HPF diagnose procedure, you need to have SAS high performance forecasting. But with these procedures, you can perform the following example that I'm going to show you here quickly. The way we are doing it is similar to what we've seen before. We're using the same data. I say I'm using the X13 procedure, which is a time series smoothing and also time series fitting procedure. And I say this passenger data that I just presented you, you see here this pattern and the trend, this follows a certain ARIMA model. I have to admit that I first ran a time series analysis to identify the optimal parameter sets, and I will speak in a second how you can circumvent that. So I say this time series uses this ARIMA model, and then I would like to get a list of the outliers which are, let's say, quite distant from this model, and I'm going to output, similar like before, I'm going to output this parameter estimates in a separate data set. Let's go and run this and see what we get. We see that we get quite a lot of output here from the X13 procedure because it fits, it moves, and it does a couple of things. What we are really interested in is this table here, as we see it here, that at certain points in time, there are outliers. In September 2001, we know there's something happened. There is a negative estimate, so the airline passengers go down. It came back a little bit in November, and then there are two more events in December 2002 and 2003. So we would like to get this table and again use it for our analysis. So we see we have the output data here, where we have the estimate and we have the time point here. However, it's not as explicit as with the ADAPTIVEREG procedure because we see this is part of a SAS state value, but it is preceded by the type, whether it's a level shift or whether it's a pulse. So you will see from the code in a second that we have to do a little bit more data management here to get the date value out of that. But the procedure is very similar to what I've shown you before. Again, I say I go and pipe this into a SAS file for the REFLINE statements. I use the file statement here. And then I have to do the following. I say, what I got here was not a pure date value, but it only starts at the third character. So I'm subtracting month and year out of from the parameter estimate, starting with the third character, and I add 0 to 1 for the first day of the month for a date value, and I add day at the end to have the typical SAS date pattern. So after doing this, I have a date value, and here I do a little bit more than before. I again say REFLINE at a certain date, what we just calculated. We put it on the x-axis, and we also add a label and say we are labeling here whether it's a pulse shift or whether it's a level shift by again attaching the dynamic value of the reg variable here. Let's take a look how this looks like. And you see we have a second file now. It looks very similar to the first one. We got the date value that we just created, which is okay, which is nice. We have on which axis, and we also got dynamically, this is a level shift in a certain month. If we now go and use this in our code, we see that we have again the SGPLOT procedure, we plot the series, and we include our reference file, and we have it in a way like you see it here. We have the time series and we say, okay, something happened here in September 2001. There's another level shift in November 2001, and there are 2 more level shifts here at the end. So this is another way how you can automatically analyze and how you can automatically label your data, and how you can get this up and running. Maybe 2 quick comments. My practical experience says if you have time series data like this and you see at the end you have a very strong decline or very strong peak, it's not necessarily the case that this happens because here the airline passengers dropped, but maybe the database, the time until all the updates from different countries and airlines are coming to the database takes some time. So this might not be a decline in passengers. Maybe this is just a data actuality problem, and that this data is still going up in the next week. So usually it's sometimes advisable if you analyze time series data, if you're not 100% sure whether you have already all the data, you omit the last month or the last 2 months. So this is what I showed you here. I also mentioned that I ran a time series analysis beforehand. If you have SAS high performance forecasting, you can run PROC HPF diagnose, which does the model fitting automatically for you. So you don't have to do this manually, it automatically finds the best model. Or there's another way how you can, for example, use the UCM procedure, which automatically does also outlier detection without having to specify an ARIMA model. It uses an unobserved components model. So this is what I wanted to show you, how you can automatically analyze the breakpoints in your data, how you can detect them, and how you can automatically label them. My question to Ellen, I know I'm already have used up all the time that we have. If you have another 2 or 3 minutes, I can quickly also show how you can, for example, combine this method. If you do not want to use it with an analytical procedure, maybe just you have business rules in a Datastep.
Yes, please carry on.
Yeah. Okay, so for example, the question now is, can I use this method in order to label something in the data also without analytical procedures? And the answer is yes. For example, if you just define simple business rules, if you say, I would like to label in the data all those months where there's a decline from the previous month of more than 10%, or if it's December and the previous month was 200, so you just define business rules. What I bring here as an example is, I would like in my example to flag all months where the Easter Sunday does not fall into April. So we all know that Easter is a movable holiday. It's in most cases it's in April, but it can also be in March. So the earliest date is 21st of March, if I know correctly. So for example, I would like to flag all months where the Easter Sunday, flag all the years where the month of the Easter Sunday is not in April, and indicate whether there is an increase or a decline from March to April. The business rationale behind this is for many areas in tourism or in restaurants, it makes quite a difference whether Easter falls into March or whether Easter falls into April, because sometimes if it's in April, you have more people already going out to the mountains and pursuing leisure activities. So maybe you would like to also label this in your data. I coded this that way that I use the diff function in SAS to see whether there's an increase or whether there's a decline from the previous to the actual month. So I coded this with the diff function. And I do the decision whether this is the Easter month by using the following code. I say, I go and write an expression, and maybe I go to the editor because there I can move a little bit around in what I wrote here. Yeah, so here you have the code with the diff function. And what I did here, I'm a very lazy person in terms of coding. I very often do not write if and else statements if I do not have to. So I just Easter month, yes or no. So 1 or 0. This is the value of an expression. So I say, if the month of the actual date equals the month of the holiday of the Easter Sunday in the actual year. So I take out the year of the date and say, tell me what is the month of Easter in that year. And there's a very powerful function in SAS, which is called the holiday function, where you can get the date for moving holidays. And especially for Easter, this is a real good advice to use so, because it's extremely hard to program otherwise. So I'm creating these two variables, and then I'm doing the same as we did before. I say I create another file name statement, and I say if the month is April, and this is not the Easter month, as we said before. And then I say if this change that I calculated here with the diff statement is negative, then I output the label and say there's Easter is in March, and in April the value decreases. Otherwise, I say Easter is in March, and the value in April increases. So this is just an example how you can do this with business rules, and I think you will have other applications for that. But I'm just trying to point out that you can combine this also with other areas here. And if we run that, we see that we now get for our data in a similar way also our difference levels, which we have here. And I say, okay, for these three time values, I get Easter is in March, and in April there's an increase, here's a decrease, here's a decrease. And we, again, with the same way as we did before, we can go and run this with SGPLOT, and we can also get a dynamic labeling of our data just based on our business rules. Here Easter falls into March, and from March to April there's an increase. Here from March to April there's a decrease and another decrease. And this is also a very nice way how you can automatically detect something in your data based on business rules and go and dynamically add this to your graphs. And this is what I wanted to show you here as my third example. Having said that, we are already at the end, and my conclusion is that it's very convenient with SAS procedures to automatically detect the structural changes. The results can be provided in lists or graphically, and very important, it only makes sense if you can automatically insert and label this data, because if you always have to do manually, this will not be an easy thing. This is what I wanted to show you here. I also provide here a list of more content. So there's also a SAS communities article on that, how you can automatically highlight the things that I showed you here. I've also have in a SAS communities article, also the thing with the movable holidays. So I quickly jump out here and show you this in my browser. So for example, there's a blog in SAS communities which you can use. There's another one how you can simulate your time series and how you can use these movable holidays, which might be convenient for you. And if you want to listen to more content that I'm presenting here, there's also, I started a couple of weeks ago, my Home Alone data science series, where I'm always publishing YouTube videos, and I'm happy to publish my recording from today also in this series. And I'm also doing SAS articles. Yeah, and that's everything I wanted to present you. And yeah, thanks for having me. And if there are any questions, I'm happy to answer them.
So let me give a small comment. So first of all, very nice presentation. I will definitely get back to the details and the codes to check it out. So it was really nice. And like off topic is that you've just reminded me that I forgot to told my students about one way of using include statement within the procedures. I was talking about include procedures this week. And I include statement. Sorry, include statement. And I forgot about this one particular example you just showed, that you can use it inside the procedures or data steps.
Yeah, this is a very powerful way how you can really create all your SAS programs very dynamically, so that you generate your code depending on data.
Yeah, I've been using the include statement very extensively when I was developing the package framework for this year SGF. Yeah, so it's definitely a very useful one.
Great.
I had one question. All of the examples shown, can they be executed in University Edition?
Can they be executed in University Edition? Definitely the ADAPTIVEREG example. I have to admit, I need to check for the ETS example, because the University Edition is limited with respect to selected ETS procedures. There are some included, others are not included, but I can easily check this after our session and give you feedback on that.
Great.
What I can also do is the code that I showed here is code which is quite similar to what I already published in my SAS Communities article. So in this one, what I will do after this session, I will add here another attachment where I add the full code that I showed you here, because it then also contains the text extension here with the dataset example. So you can also have this one, and I will also add a note what can be run in the University Edition and whatnot.
Fantastic. Then, yeah, I can see your contact details are on the screen, and I would like to just say a big thank you very much.
It has been a big pleasure, and always happy to come back for more discussions and for more presentations.
Yeah, this one was really cool. I liked it a lot. Thank you.
Thank you. Thanks for joining.